everybody, I'm Tyler.
Matt?
We're with VIAVI Solutions, and in this episode, we're taking a closer look at some of the challenges with polarity for multi-fiber connectors. Matt, tell us a little bit. We've heard this term a lot with polarity, even with single fiber connectors. Tell us a little bit more about what that's all about.
Yeah, so polarity is essentially making sure that the transmitter on one end of a link is connected to the receiver on the other end of the link, and the transmitter on the far end is connected to the receiver on this end. If my transmitter is talking to that transmitter, there's not a link, right? The link isn't up. Nobody's receiving the data. So it does exist in duplex connectivity. In a duplex LC is usually used to connect one SFP to another SFP because one's talking in one direction and one on the other. Those can get messed up, right? A lot of people would know from personal experience that you can get those two lines flipped, and it's relatively easy to fix. Can be troublesome, but you can find it and you can fix it. With MPO, it just gets really complicated because I don't have one fiber on this connector and one fiber on this connector. I've got 12 or 8 or 24 fibers locked into position on a connector, and I can't change them. So with MPO, I may be putting different traffic down each pair on that 12 fiber. That 12 fiber MPO may be 6 separate channels, or it may be one that's talking on these 4 fibers and listening on these 4 fibers. So it can be used in a bunch of different ways, and maintaining that transmit connected to receiver, receivers connected to transmit each of the transmit fibers connected to the right receivers on the other side, and vice versa, becomes really complex with MPO.
So you don't necessarily just try to make sure that you got the right person talking aligned up with a general listener. You need the right talker and the right listener.
And there are many different. Again, you can have many different channels. One channel you can be using the MPO for. It's complex. So we standardized this a bunch of years ago. So you might hear about these Type A, Type B, Type C polarity. Yeah. So what that is a defined methodology of building the link. MPO is even more complex because not only is it where are all the fibers, it's the MPO has a key that controls how the fibers are connected from one connector to another connector. So if you've got this key up on this side, key down on this side connector, this MPO comes in like this MPO comes in upside down, this fiber gets connected, pinky fiber gets connected to index fiber, right? If I'm key up to key up, pinky fiber talks to pinky fiber. None of them are wrong. They all have solid design behind them to assure that the link connects the right fiber on this end to the right fiber on the far end. But if you mix up, but they all use different components, and if you mix the components up, you will scramble the signals going off in all kind of different directions. So it's very easy to get wrong, and you can't figure it out. So so if we look at a duplex LC, talking to 2 SFPs, you're connected through, you're trying to plug them up, it's not working. You call your buddy on the other end, he puts a VFL on his transmit side, you look and you go, oh, it's coming out on my transmit. I've got my connectors flipped over. So you can kind of flip your LCs around, plug them in, you fixed it.
That's easy, yeah.
You can't fix it on MPO because you can't move the fibers. You can't even figure out what's going on because you shine a light on the MPO on this side, it's just coming out of all the fibers on this side.
Glowing.
So you can't like look and say, oh, you're on fiber number 2. You can't tell. Vendors out there sell systems that are really heavily designed to go in and work right on the first time. And so on an initial build, when you're building it out, you're using all the same vendor stuff, you're using all the right part numbers. Another part is you got to get the bill of materials for the build right. You can easily, if you mess up on what you're ordering when you put this link together, unfortunately, I got one of the wrong cables in place and it flipped everything over. So ordering wrong can impact it, but usually that initial build goes fine. Now somebody comes to turn up services and add patch cords. Are they using the right patch cord for the system? Or you had a legacy system that was MPO, that had MPO trunks,
an upgrade scenario,
and went to LCs, and now you're saying, well, I'm going to go parallel optics. I'm going to rip out the module. I'm going to put in a panel. I got my MPOs, and I'm going to connect through to the QSFP. That's a legacy built system. I don't know when that trunk was put in, or those trunks were put in years ago. Now, are you getting the right patch cords? So there's a lot of ways for it to go wrong.
You brought up something really interesting, and this is a scenario where we're seeing MPO used a lot. It was an investment that they made several years ago in an architecture that was for an easy plug-and-play rollout, and now they're saying, hey, I can still use this multi-fiber architecture as I'm migrating, say, up from 10 gig to 40
Right.
gig. But the challenge now is, like you just described, hey, I don't know what kind of polarity I have.
We'll talk about pins in another video series that comes into play. So again, MPO is just very complex. So the takeaway is that you need to test it, right? If you're building on an MPO link, you need to verify that that link has its correct polarity. It's in 568. I mean, 568 since this duplex connectivity said one of the things you're verifying with this test is loss, length, and polarity, that you're routed correctly. So you got to test it when you're building a link. You should be able, if you're going to troubleshoot one of these links, you should have a tool that can identify one line on the MPO versus from another line or fiber on the MPO. And so there are very few tools out there that do that, right? You need a light source and a power meter that have MPO ports on them and can individually determine, I'm sending you power on line 2, I'm receiving that power on line 4, oh, that's wrong. Or, oh, that's what I expect, that's how this thing is mapped out and built. So you need an MPO designed test tool that can verify that polarity if you're going to know what's going on. You can't do it visually. You can't do it with a VFL. You're kind of in the dark.
Yeah, makes sense. Well, thanks again, Matt. Until next time, I'm Tyler.
And Matt.
And you can find out more information at viavisolutions.com/MPO. Thanks for watching.